Okay, everybody. So here's my second part to the video about the law of sines. So in the previous example, we looked at having two angles and one side, right? Two angles and one side. We were looking for a third side. So in this set of examples, what we're going to have here is I'm going to concentrate on the top triangle first. But if you notice what they have in common, right? They have the 10 inches as side AC. I'm going to keep that constant. That's staying the same throughout both examples. There's going to be two different examples here. They both also have 33 degrees, so I have those highlighted. Those will stay the same. So here's what I want to talk to you about. The first one I want to try is the top one. Now what I'm going to do is I'm going to use the entire outermost triangle. I'm going to ignore that information in the middle, okay? So I have this outermost triangle ABC. AC is 10 inches. Angle C is 33 degrees, and now we also know the side that is opposite of 33 degrees, okay? And that's 6 inches. We'll get to the other one in a second. So we should be able to use our law of sines when we have two sides and one angle. They call this the ambiguous case, right? Because ambiguous means left open for interpretation. So they call this the ambiguous case because we do get two possible answers. So what I want you to notice is I think that angle B here looks to be, and if this is drawn to scale, looks like it's an acute angle. Where in the next case, we're going to move things and change it so that B is obtuse, all right? But we'll get there. Let's start with this first example, and I'm going to start to set up my law of sines. So I'm going to say the sine of 33 degrees is to 6. Sine of 33 degrees is to 6 as what? Well, if we're looking for the measure of angle B, right, and that's what we're going to do in both cases, then I don't know the measure of the angle. So I'm going to use capital B. If you want to use theta, you're more than welcome, but I'm going to use capital B. So I'm going to say the sine of 33 degrees is to 6 inches, as the sine of B degrees is to 10 inches. Now, if you notice right from the beginning, we're going to need to find an angle measure, so we're going to need to access our inverse trig buttons on our calculator. So I'm going to cross multiply. After last video, I think this should be pretty quick by now, right? 6 sine of B equals 10 sine of 33. What do I need to do here? Now, this is slightly different than our last example. I don't know the sine of B, and this is a package deal, right? Sine of B stays together, so what I'm going to do is divide by 6, okay? Now I'm going to say the sine of B equals whatever that value is. Now I'm going to take my calculator out now. I wanted to show you this, okay? So I'm going to have 10 sine 33. That's my numerator. Now I got to divide by 6. So it's about 0.907. So I'm going to say it's about 0.907, et cetera, et cetera. But notice I'm leaving that set of decimals on my screen. So what I need to do now is undo the sine of B. And in order to do that, I'm going to use the inverse sine, right? So I'm going to show that. I'll use in red so it looks a little different, right? So the inverse sine will cancel out the sine, leaving just B, okay? Now what we do to one side, we'll do to the other. So I'm going to write inverse sine of 0.907. So on these calculators, I showed you during the school year that we can take here inverse sine, and I want to pull my previous answer, so I'm going to hit second negative. If you want, guys, just type in 0.9077. It should be fine. Okay, so after taking the inverse of each side, I'm going to get about 65.19 degrees. So 65.19 degrees, and that is going to be the measure of my angle B here. So this example's done, okay? We have the measure of the angle. So now what I'd like to talk to you about is this. All right, we said this is the ambiguous case because there's two possible answers. So in the bottom example here, right, notice we're keeping 10 inches constant. That's the same as the previous example, right? We also have the 33 degrees here. But I want you to consider A as like a swivel point or a hinge point. So what I want to do is pretend like this is, like a spinner at a beach boardwalk game. You know, I want to be able to flick that spinner and it should spin over to here until it lands on the bottom of the circle, okay? Excuse me, on the bottom of the triangle. So I want you to notice what happens here. I'm now going to use this triangle here, okay? I'm going to ignore all this nonsense, Okay, so what I now have is, again, AC is still 10 inches and C is 33 degrees. But we've rotated this segment over to here. Now look what happened. I think if we were to try to find the length of BC, that would be shorter by now, right? But I want you to focus here on this angle measure here at B. It appears now, after swinging this segment in, it's an obtuse angle. So let's see what happens here. I'm going to use basically the same thing we just did, except now if we take a look, right? Oh, wait a minute. If I write my equation, whoops, the sine of 33, oh, that's going to bother me, is to 6, excuse me, as what now? But wait a minute. The sine of B is to 10. So wait a second. We actually have the same exact proportion, okay? But what's actually pretty cool about this is, if you notice, right, these two angles, right, B and this new angle at which we're calling B prime, think about it. I think those have to be supplementary, don't they? Because don't we have an isosceles triangle here, 6 here, 6 here? So this angle, which was 65.19 degrees, is also the same here. But then these two angles are supplementary. So there's a nice quick shortcut to this. You would actually solve this triangle the same exact way, but in order to get this angle here at B prime we're calling, I would just simply take 180 degrees minus that. I would find its supplement, right? And since I still have that on the screen, I can do 180 minus previous answer, and that would be approximately 114.8 degrees. So I'm going to say the measure of angle B prime is about 114.8. All right, ladies and gentlemen, I hope that helps. I was a little sloppy here, but I'll fix that. All right, again, let us know if you have any questions. Have a great day. See ya.